Hello everyone, let's solve some Leetcode today. So today we have Leetcode 1046, that is last stone weight. In this problem we have been given a stones array, and in that array we have been given the weight of the stones. And now we are playing a game with those stones. So in each turn we have to choose the heaviest two stones from the given stones and we have to smash them together. Okay. Now suppose the heaviest two stones have the weights x and y, where we are assuming that x is going to be less than or equal to y. The result of the smash will be if x equal to y, then both the stones will be destroyed. Nothing will be remaining. If x is not equals to y, the stone of weight x will be destroyed and the stone of weight y will have a new weight. Okay. And here the question is saying at the end of the game, we will have at most one stone left and we have to return the weight of the last remaining stone. If there are no stones left, we simply return 0. So basically we have a lot of stone A, B, C, D, X and Y in an array, and we are playing a game with these stones. Now in the game, at each turn we are supposed to take two stones out of this array. So we are going to take the two heaviest stone. So we suppose that X and Y are the heaviest stone till now in the array. So we take X and we take Y. And now we are saying that if X equals to Y, then both the stones are smashed together and both of them gets destroyed. And if they gets destroyed, we don't really have to do anything, correct? We just can go to the array and get next two heaviest elements, suppose C and D, and we play the game with C and D in the next turn. Simple. If x is not equals to y, we are saying that x will be destroyed. So x will not be there anymore. And the y will actually become y minus x. Now y minus x will always be positive. Why? Because here we are saying that x is going to be less than equal to y. But then again, this condition has been stated in the question itself. While we are coding, we can simply use absolute function to get the positive difference between y and x, so that we will know that okay, it's always positive. And now this thing, the y minus x, will give another stone, right? So new stone will be this one. And since we have a new stone here with a new weight y minus x, we can actually put that again back into this array so that we can play with this stone also in the next turn. So that's what we are supposed to do in this question. So based on the discussion that we have done till now, let us try to understand how we can actually solve this question. So we are supposed to get two heaviest elements from this array in each turn. So suppose that we want S1 and S2 at each turn. Now nowhere in the question it is mentioned that the array is sorted. It means we can have any random order of the elements. So how do we get the two most heaviest elements from the array? Well, one way is to actually sort it. You can go ahead and sort the stones array and get the two heaviest elements from the end or from the starting based on how you are sorting. So yeah, you can actually sort it. Suppose we sort it in the descending order, so it will become 8, 7, 4, 2, 1 and 1, and then we can just get the element from the starting of the array each time and then smash them and then put them back into the array, sort it again if we want to. So yeah, we can do it, but this is going to take at least order of n log n. So this is actually coming from the sorting part. That's why the overall time complexity for this thing will actually become n log n. But as I already said that we can actually do better, so let's look at that solution. Now let us try to understand what exactly do we need to do in each turn. So in each turn we are supposed to get two heaviest elements. Right now the heaviest elements are 8 and 7. Great. So how do we get these in the minimum time? So if we really notice, we will know that the condition is that each time we take out something from this array, it needs to be the maximum element in the array. We are not really worried about the order of the other elements. The order of the other elements can be anything. But each time we are taking an element out of the stones, it needs to be maximum. And this kind of property where we are saying that we need the maximum element from the given elements each time I'm taking out the element, this kind of property actually exists for the heap, specifically max heap. So max heap will give you the maximum element from the array each time you are taking out the element from it. And the order of the other elements does not really matter, because each time I take out an element from the max heap, the max heap will readjust itself in log n time to get the next maximum element at the top, and then we can just get the 7. And so that is pretty efficient. And so it means the time complexity for taking out an element is log of n. Similarly, insertion is also log of n. So these are the properties of max heap. You should learn about max heap if you don't know about it. So we will have a max heap here and we will just put all these elements into the max heap. Now I am going to put them in the sorted order just for the ease of explanation. But understand that they don't have to be sorted order. Each time you create a heap from the given elements, They can be in any order. The only thing is that the maximum element will be at the top always. So let us try to create the heap. So we have our condition fulfilled. We have the 8 that is maximum at the top, and rest of the elements are below it. Now it looks like a stack, but it is not a stack. Okay, it's not stack, not stack. It just looks like it because I'm just trying to explain you how the min heap works by taking out the element at the top which is maximum. So first we will take out the two elements that are maximum. I will take the first 8. The 8 has been taken out. The heap will readjust itself to make sure the 7 is at the top. So 7 will be next taken out. And now the heap will readjust itself to have 4 at the top. Great. And now we play the game with S1 and S2. So this is S2. So 8 and 7 are not equal. It means they both will not get destroyed by each other if I smash them together. So they are not equal. So all I need to do is get the difference between 8 and 7. So 8 and 7 difference will be 1. So the weight of the new stone equals to 1. And now that we have 1, we are supposed to put it back into the heap. So if I put it back into the heap, I will have another element here. Now here I'm adding it at the end, but it doesn't have to be at the end. It can be in the middle of these two ones or at the top of the ones. It depends on the heapify function that we are going to use. So as I said, the order of the elements does not matter. The only thing matters is that the top element in a heap is always the maximum element or the minimum element depending on which heap you are using, max heap or min heap. So basically 8 and 7 are gone. So I will now take out 4 and then I will take out 2. So I will have now 4 and 2 in the next iteration. Now 4 and 2, they are also not equal, right? They are different. So what I will do is I will have a new stone that is 4 minus 2, that is 2, and then I will again put this 2 into this heap. So the 2 will come somewhere here. So as we know that we actually removed the 4 and 2, but we are again putting the 2 back into, so the 2 can come here. So we again have 2 in the heap. And now we have 2 and 1 as the next maximum elements. So we will just use them, 2 and 1. Now they are again not equal. So we will simply say new stone is equals to 2 minus 1 is equals to 1. And now we will put 1 into the heap. And earlier we removed this 2 and this 1, right? So the heap function can place the 1 here again. So we have 1, 1 and 1. 3 ones in the heap. So I will take the next two maximum elements 1 and 1. Then we will have 1 here and then 1 here. And these are both same, so they will be destroyed, right? So we don't have to put anything back into the heap. And then this is gone, this is gone. So the only element that remains is 1. So the only element that remains is 1 and we don't have any other element. So we cannot continue the game with a single stone. So we end the game and we just return the weight of this particular stone, whatever it is. So this will be returned. And that's it. This will be the answer. Now, in case we have nothing in the heap, everything gets destroyed, we can simply return 0. That is, we have no stones left anymore. Now let us go through the code. Now let me tell you that I'm using Python, and in the Python we don't have the concept of max heap till yet. We can only create min heap. And that's why there is a clever way to actually get a max heap from a min heap. So yes, here I am creating a min heap, but what I'm doing is that I'm setting the value of the stones as negative. So here I'm running a for loop for the stones and I'm just setting the negative value of the stones in the stones array. Basically, I'm taking all the values in the stones and just turning them into negative. And then I'm using the heap q.heapify function from Python to turn this stones array into a heap. And now since stones array actually contains everything as negative of its original value, the min heap created by this line will actually act as a max heap for us. Let me show you how. So here we have a while loop that is actually representing the game that we are playing. We are just running this while loop till the length of the stones array is greater than 1. So if we ever reach a point where the length of the stones array is 1 or 0, we end the game because we know that we have found the answer. And now at each iteration, we are taking S1 and S2. So here you can see that I'm using the negative sign. Why? Because everything in the stones was already negative. So in order to get the original value, I will take out the stones value and I will make a negative of it. So as you can see here that S1 will be positive. So I'm popping the element from the stones heap and I'm turning it into negative just to get the original value back. And once this line runs, the stones heap will actually readjust itself to get the next maximum element at the top. And once that happens, in the S2, we will actually get the next maximum element at the top. And here also the heap will readjust itself to get the next one at the top. Now here we are checking if S1 double is equals to S2, we do nothing. Everything is destroyed. We just take out the stones and just throw them away. So we will simply say, okay, continue. Let's move on to the next iteration or next turn. Otherwise, if they are not equal, we know that after smashing them, we will have a new stone and we are supposed to put that new stone into the stones heap. We are calculating the new stone S1 minus S2, the absolute value, and then we are storing the negative of this absolute value of S1 minus S2, that is the new stone value, into the stones heap. Remember that this step we are doing only for Python. In other languages or in other places, you don't really need to use this because there is a concept of max heap there. But for Python, we have to use this clever way of using negative sign to actually just, create a max heap out of a min heap. So now once we have pushed it, the heap will again readjust itself to get the maximum element at the top. And once this while loop is actually done, we will have either one element into the heap or we will have nothing. So that's what we are doing here. If there is any element into the stones heap, we will return that element. And of course, we are actually adding the negative sign to return the original value that was actually present. Otherwise, if the length of the stones is not greater than 0, we know that nothing is there, everything is destroyed, so we will simply return 0. This is a short way to do this in Python. In other languages, you might actually have to use if-else statement properly. So yeah, let's try to run this code and see what happens. So yeah, our solution runs and passes all 74 test cases. It runs in 0 milliseconds and beats 100% of the solutions on Leetcode. Although this number is very questionable, I mean, how can you run 74 test cases in 0 milliseconds? Maybe you are using nanoseconds or something, but yeah, you can understand that it's a pretty efficient solution. Now let us look at the time and space complexity for this solution. Now here the space complexity is order of n, and I'm pretty sure that people know why it is. We are using heap, and in a heap, we can actually end up storing n elements in the worst case. So that is why we are saying order of n for space complexity. The interesting thing is order of n log n for time complexity. As I have already told you that sorting is not a good way to solve this question because it will take order of n log n at least. And so you might be thinking that why am I using heap then? If it is the same time complexity, why the heap? Well, let me tell you that it's not the same complexity. So by using sorting, you can actually solve this question in two ways. Either you sort the stones array one time in the starting and then just use that array, or you can sort the stones array each time into the while loop. So in case when you are sorting the stones array earlier without the while loop, what will happen is that in the while loop, you may actually get a new stone and you will put it into the stones array. And now you don't want to sort it again. So what you will be doing is, in order to put it into the stones array, you will run a for loop inside of this while loop to check where should I place this new stone value. And once you find the new stone value that okay, this is where you can place it, you will have to shift the already existing elements towards right side just to accommodate the new stone on this place, right? And then yes, there will be some elements in this side also, but you will definitely have to shift the elements, and that can take like order of n in the worst time complexity. So finding the place in the stones array where the new stone should be and then adding the new stone into that place by shifting the rest of the stones to the right, this entire thing will actually take order of n time. Why? Because first of all, you are going through the elements that are not supposed to be shifted, then you find the place where you can actually put the new stones, and so you put it there and you shift the rest of the elements to the right side. So in this entire operation, you actually traversed each and every element in the array only once. So that's why order of n. But then what will happen? Since we are using a for loop inside of a while loop, and that for loop can actually run for order of n, the time complexity for this will actually become order of n square. And which is just not good, which is worse than order of n log n. Now in case you just said, okay, I don't want this thing, I will just remove it, I will sort the array each time inside of the while loop, your code will look something like this. You will have a while loop, you will play the game, then you will get a new stone, you will put it into the stones array, and then you will sort it. Now in the first iteration, the sorting will take like n log n. Now in the second iteration, we will have like one less element into the stones array. Why? Because one of the elements got destroyed, correct? We took out 2, we just put 1 into it. So one element or one stone must have been destroyed. So in the second array, when we are sorting, we will have n minus 1 elements and then log of n minus 1. Similarly, in the third iteration, we will have, and once you have add up all of these, you will get a time complexity of order of n square log n, which is definitely worse than order of n log n. So that's why we did not use the sorting algorithms. We simply used the heap algorithm. So now I believe you can appreciate the heap algorithm far better. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then just let me know in the comments. Now we will meet in the next video. Till then, bye.